So, we're going to fill in a few things here. So, when we're talking about functions, they're one of the most important things that you're going to deal with in algebra. Functions are types of relations. A relation is a relationship between sets of values of order pairs. So it could just be like a group of points, like a list of values. It could be an equation that represents those. But a relation doesn't have to meet certain standards that a function has to meet. So a function is an expression, rule, or law that defines a relationship between variables where x values do not repeat. So, have any of you guys had Coach Wood? Even for Math 1? You had Coach Wood for Math 1, okay. You also, okay. So, I don't think I had anybody in the other class that had Coach Wood. But, if you had Coach Wood, I don't know if he did domain in Math 1, but for domain, he would start singing All My Exes Live in Texas. Did you do that in class? Yeah. That is because domain is your possible x values. You may ask yourself, all my exes live in Texas. What does that have anything to do with domain? But according to him, all of my exes live in Texas. Dallas is in Texas. Dallas starts with a D like domain, so domain means that that's your x values. So easy. You'll be able to remember that easy. Now, no problem. Range is going to be your y values that you're looking at. And we're going to talk more about domain and range tomorrow. We'll have a whole section of notes on how to tell what your domain and range is. But we're just going over some basics right now. All right. So, you guys may remember doing this for Math 1. Some relations can be as simple as just like a list of points. So we've got this list of 5 points right here. If you have something like that, your domain is just your x values. So you would just list these 5 x values. If there were one that repeated, you would not list it twice. So you'd have -4, -3, 0, 1, 3. You don't even have to put them in order. These happen to be in order, but you can just list them. Your range, on the other hand, is going to be your y values. So y is your second coordinate. So for this particular problem, you'd have 0, 1, -2, 2, and 3. So that part hopefully is some review. When I say like you've already seen this in Math 1, I realize you've probably forgotten some things from Math 1. At the end of Math 1, a lot of my kids had forgotten things from Math 1. So I realize you've forgotten, but hopefully you'll be able to get it back a little bit quicker. These things that we have seen before. We need to know if this is a function. And so whenever you're asking yourself, is this a function, you're going to think here, do the x values repeat? Okay, if you have an x value that repeats, so you've got a -4, 0, and then maybe a -4, 2, then that is not going to be a function. If the answer to that question is no, they do not repeat, that is a function. If it is yes, they do repeat, that is not a function. So in this particular case, whenever we look at this problem, Silas, is this one a function? Yes. It is, yes. Your x values do not repeat, so this would be a function. Okay, we're not going to see a lot of this in this level of the course. It's more of like a Math 1 thing that you would do. What we are going to see a little bit more of is looking at these from the graphs, particularly with domain and range. We're going to look at it a lot tomorrow. So for the graphs, there is one thing you have already hopefully done and another that I'm going to throw on you that's going to be new. You should have in Math 1 learned about the vertical line test. The vertical line test says if a vertical line touches the graph of a relation only once at each point as it is passed through the graph, the relation is a function. So we put function right here. Okay, so if we have that vertical line and it only hits at one point everywhere, then that is a function. Okay, I'm going to add one more thing in there on top of that that you didn't talk about in Math 1, or at least I don't think so, is the horizontal line test. It's the exact same thing, but with a horizontal line. So we're going to take a horizontal line, we're going to pass it through, and we're going to see if it hits more than once. So this is going to be important when we get to inverses, knowing if something is this type of function. So if it can pass the vertical line test and the horizontal line test, so we got a relation that passes vertical and horizontal, that is a special type of function that we're going to call a 1-to-1 function. So each x only has one y and each y only has one x. So that's a special type of function, one that you probably haven't seen before, but it's pretty easy to identify. Let's look at a couple examples. So we go to the next slide here, and where'd my vertical line go? All right, so you're going to take a vertical line, any pencil, work, finger, whatever. Vertical line, you're going to pass it through. If it hits at more than one place, as it is doing here and here and here and here, then that is going to be not a function. So for example 2, we would have not a function. Right, that's because a vertical line there is going to hit at 2 places on the graph. Both of those places have the same x value on that x-axis. You know, here this is like -2, 2, and this is -2, -2. Right, that x value would be repeated whenever this is happening. So, example 2 is not a function. What about 3? 3 going to pass a vertical line test. Does it hit twice anywhere? It does not. Okay, so since it does not hit twice anywhere, we know this is going to be a function. But we also want to go a little bit further than we did in Math 1 and ask the question, is it a 1-to-1 function? So we're just going to take our vertical line and turn it horizontal, and I'm not calling them to do this well. But we're going to see if that horizontal line crosses more than once. Does our horizontal line cross more than once? For this it does. It's going to hit like 3 times in some places, right? Not everywhere, but it only matters just like one time, and it's going to, like right here. We're going to hit 3 separate places. So this is just a function. It's not a 1-to-1 function. It's just a function. Notice I didn't even do the horizontal line test on this one, because if it's not a function, you really don't care. It can't be 1-to-1. It actually does pass the horizontal line test if you were to do the horizontal line test, but it doesn't really matter for us because it's not a function to begin with. So questions on that? All right, let's go to the next slide. Oh, wait. I did that one. Okay, so I'm not going to have you guys get your computers out just for this one little bit. But we are going to use Desmos here. There are ways that you can tell just from an equation whether or not something is going to be a 1-to-1 function. However, we have 83 days to do way too much stuff, so we are not going to go into how to do that. We are going to use Desmos. We also are going to mark out example 5 because I just put the same problem over again on accident. So So if you get one that is an equation like this, we're just going to type it into Desmos, which I'm going to do for you here. We got y equals x to the second plus 2. So whenever I look at this one here, let's see, let me practice some names. Oh gosh. Over there in the corner, I can't remember. What is your name? David. All right, David. Would this one pass the vertical line test? So if we had a vertical line, does it hit more than once anywhere? No. All right, so that means that it is going to be a function. It's going to pass that vertical line test. So we would say that this one is a function. We also need to check and see if it's a horizontal line test. Or a horizontal line. So if I put a horizontal line like this green one that I have here, David, does it pass the horizontal line test? No. So it is just a regular function. It's not a one-to-one function. Okay. We're not going to do example 2 because it's, or example 5 because it's the exact same. Let's go back and do example 6. So 3 to the x power. So let me move these out of the way. That is this graph right here. So, Caroline, what do you think? Is this going to pass the vertical line test if we move? Yeah. It does. So it passes the vertical line test, so we know for sure it's a function. We just have to ask ourselves, is it a one-to-one function now? So, Silas, what do you think? Does it pass the horizontal line test? Okay, think so? The only part that looks like a little suspect is right here. Because it starts to get awfully flat right there, right? Like it's constant. But if you know much about exponentials, which you learn a little bit in Math 1 about, if you zoom in, it doesn't actually touch that line. It's what we call horizontal asymptote. So, and we're going to learn more about that in this class. So it doesn't actually touch, so it does pass that. So this is a one-to-one function. So we'll call it 1-to-1 function. So if you see some that are equations, you're going to type those in Desmos. Do it like we did the graphs. There. All right, questions? I moved everything. Yes. That's unfortunate. Let's see, we're going to have to put those down here. You can keep those. We'll need them tomorrow. Sorry about that. Okay. All right, let's move on. So function notation is something really important that we're going to use a lot of. Sometimes we would just write y equals 3x plus 1. And that works very well. But there's a lot of instances where we need to know, we maybe have 3 different equations. And we want to call this one f and this one g and this one h. That way we can tell which equation we're talking about. So, so in our blanks here, this here, whatever is inside of your parentheses, it's your independence variable. And then this part over here, this whole phrase is your dependent part of the graph. Whatever letter is here is going to be the letter that you see them use in the equation. It doesn't always have to be x, but x is a really common one that we use. It allows for individual function names. Sorry, I'm having to avoid confusion as to which function is being examined. So we can use it to tell apart different equations that we're using. It also easily identifies the independent variable in the problem. This is really helpful when we're doing things in context, like if they use a t instead of x. a lot of times that T stands for time. So you know that you're plugging in time for that T there, and that's what everything else depends on. Okay. Questions? All right, let's keep going. Uh-oh. Why is it not going anywhere? Why won't it go to the next one? All right, click here. Let's try just starting this maybe over again. Okay. All right, so evaluating functions. To evaluate a function, we are going to plug in the input for the function's independent variable. Which is typically x, but doesn't have to be. And so what you're going to do here is you're going to replace the x with the number or the or expression. We're going to mostly deal with numbers. We'll do a little bit with expressions. So this should be hopefully familiar notation, things you have seen before. So if we have something like f of x equals 3x minus 5, and it asks us to find f of 4, what that means is plug in 4 for x. So we're going to do, we can label it. We can label it f of 4, but that's really just labeling it. It's not like something we've got to actually do any work with. And we're going to just, where that x is at, we're going to put a 4 instead. I encourage you to always put parentheses around it. So, order of operations, who can tell me what I need to do first there? Okay, parentheses come first. We kind of have parentheses here. Do we have anything to do inside of the parentheses? We do not. So after parentheses, then it is exponents. Do I have any exponents? No. All right, then what comes next? Multiplication and actually division. These two kind of like go together. So if you had division before multiplication, you would do it, but we don't have division. We have multiplication. So we need to multiply here. 3 times 4 is going to give us 12. We'll just copy everything else down. And then after multiplication and division, we got addition and subtraction. Again, we do that from left to right. So sometimes you might do subtraction before addition. So we got 12 minus 5, and we're going to get 7 for that. So that would be our answer. I don't know why it's not going to the next slide anymore. It did it before. I have to. This is annoying. I don't usually use Google Slides, but I'm trying to switch my stuff over to it because my Smart Notebook program is a little glitchy, but this is not working out the best either. All right, so if we have something like example 8, okay, I did say you can use calculator. I just don't want us to have to get up and get them with 13 minutes left. So we're going to do these without a calculator right now. But you can use a calculator on this. One thing I need to warn you about if you do use a calculator. If you're plugging in a -3 and you're not putting parentheses around it, you are going to get messed up here. So when you type this in, just like we do whenever we actually write it down, 2 times -3 squared minus 3 times -3 plus 2. You want to put parentheses around that negative 3 whenever you plug it in. And it can be done in the calculator, and like I said, even though it kills me, because I want you to be able to do this without a calculator, I'll let you use the calculator on everything, and if you do, it does a pretty good job on this one, except for I didn't put the 3 right there. Negative 3 plus 2. I will warn you, the next one it's not going to do quite as easily unless you type it in correctly. So we're getting 29 here. To do that by hand, you'd have to do exponents first, so that'd give you 9. Then 2 times 9 would be 18. Negative 3 times negative 3 would give us positive 9, and then a positive 2. And so that would give us 27 plus 2, which would be 29. Okay. What you have to be careful of is sometimes the calculator will lie to you. Wait, I'm doing that wrong. Because let's look at this next one by hand, and one way you might type it into the calculator. So we'll do 1 plus 2 over 4 times 2 minus 3. So we would do the top of this first, and we would get 3. And on the bottom, we would need to multiply first, so we'd get 8 minus 3, which would give us 5. So we'd have 3 fifths. You can just leave that as a fraction, or you could do a decimal if you want. It would be 0.6. So this is the correct answer. Look at what happens if I type it into the calculator like this. I get negative 1 as the answer. It's not going to do it correctly if you just type it in. Because what's happening is it needs, if you do type it into the calculator, you need parentheses around the top. Just don't show it at all. Parentheses around this top part and around the bottom, which actually makes it kind of complicated to type in. You would have to do parentheses 1 plus 2, close parentheses, divided by 4 times 2 minus 3. You got to close those parentheses, so you got to have those extra ones there. So I find it easier, especially on this one, just to do it by hand when you got pretty small numbers there, and it does give us the right answer there. Do you guys know how to turn it into a fraction on the TI-84 calculators? I know we don't use them that much anymore. Okay, let's write this down right now. If you, because I want to use these some, not exclusively, but we are going to use them some. So decimal to fraction. On the 84, you're going to press math, enter, enter. So if you're here and you just got 0.6, but your answer choices are in fractions, you can go math, enter, and it'll change it to a fraction for you. You guys know how to do it in Desmos? Let's look. Desmos, let's say we got 0.6. In Desmos, right over here next to the number, there is a button that looks kind of like a box over another box. That's your fraction button. If you hit it, it'll give you the fraction for it, for that. So there's some tricks if you didn't know how to deal with those. All right. Let's look at our last ones. The last one here on this slide. Any questions so far? I know this is the first day, and if you have questions, let me know, because sometimes I might tend to go too fast through things. So this one actually asks us to find R of 5, R of 20, and R of x squared plus 4. Don't worry about that one when we get there. So R of 5, we would just plug 5 in, so we get square root of 5 minus 4 plus 2. There's not parentheses in this, but what the stuff that is underneath the square root, it's like there's parentheses around it. So 5 minus 4 is going to give us 1. What is the square root of 1? It's just 1. So we got 1 plus 2 right there. And that's just going to give us 3. So 3 would be our answer for part A. Okay, for B, we're going to do the same thing. 20 minus 4 plus 2. So we got 20 minus 4 is going to give us 16. Okay. Sawyer, what's the square root of 16? 4. So we got 4 plus 2. We're going to get 6 on that one. All right, let's look at C. C is a little bit tricky. This is getting up into that like honors level of stuff. We're going to do a little bit of it. Ms. Martin's notes had more of it. I took some of it off. Let's look at plugging that in for our P. All right, so it's going to look like this. Where that P was at, we're going to put x squared plus 4, just where that P was at. So we still have minus 4 there, and we still have this plus 2 out here on the end. So inside of the square root, we've got x squared plus 4 minus 4. So what happens with that plus 4 and minus 4? Cancel each other out, just equals 0, right? So that means since they cancel each other out, I really just have square root of x squared plus 2. And what is the square root of x squared? It's x. Very good. I'll have to put it over here. X plus 2. And you really can't simplify that any further, so you have a variable in your answer here. We're not going to do a ton of that with the variables. We'll do a little. All right. Okay, so at the end of this, there are some questions for you to practice. So you have a few about functions, and then you have a few asking you to evaluate. So I want you to go ahead, and then this last one, we may or may not get one. We're definitely not going to get to it probably today, but this is a little bit of a stretch. So what I want you to do for definitely do 1 and 2, and see if you can get number 3 done. There, and then if you can get all 3 of those done, you can go ahead and pack up, because it is, I'm pretty sure we're out of here at 1:15. Yeah. So see if you can do all 3 of those. And then the last little bit we'll look at tomorrow.